Welcome to our deep dive. Today we're pulling from historical texts, mass research, and a bunch of computing milestones to trace the history of modern AI chatbots.
Yeah, and it's a really surprising history, honestly.
It really is. Our mission here is to show you how this cutting-edge tech isn't actually new at all. It's built on a thousand-year-old trick.
Which sounds kind of crazy, right? But think about the last time you asked a chatbot to, I don't know, write a poem about a toaster in the style of Shakespeare.
Yeah, it just spits it out instantly. And it feels like the machine actually understands you, like there's a little poet inside the screen.
It gives that illusion perfectly. But underneath, it's really just doing one incredibly simple thing billions of times over. It's just guessing the next word based on statistics.
Right, which brings us to that thousand-year-old trick. The sources take us all the way back to Baghdad, around 850 AD, to a scholar named Al-Kindi.
Right. He realized that language isn't just random, it actually has measurable mathematical statistics. And he used that realization to crack secret codes. Yeah, because if you know that E is the most common letter in English and you see the symbol X showing up the most in a coded message, well, X is probably E.
So the whole foundation of AI is essentially just code breaking.
Pretty much, yeah.
But it took this really petty argument in 1913 to turn that into actual math. There was this mathematician in St. Petersburg, Andrey Markov.
Oh, yeah, the feud with Nekrasov.
Yes. Nekrasov claimed that statistical laws only applied to independent events and used that to argue that, math proved human free will.
And Markov was having none of it. Just to destroy Nekrasov's premise, Markov spent weeks manually categorizing the first 20,000 letters of a Pushkin poem.
Eugene, Onegin, right?
Exactly. He categorized them as vowels or consonants. And he proved that even dependent events, where the next letter depends on the previous one, they still obey statistical laws.
So he basically defaced a masterpiece with math just to win an internet-style argument.
Yeah, that's exactly what he did. And these became known as Markov chains.
Which proved language is predictable. And by 1948, Claude Shannon applied those chains to English, which generated these, semi-coherent phrases.
But progress totally stalled out after that. There was just massive overpromising in the field. Like in 1954, IBM and Georgetown staged this huge spectacle translating Russian sentences.
Right, they promised fluent machine translation in 5 years or something.
Exactly, and the tech just couldn't deliver. By 1966, the ALPAC report exposed that the translation was terrible. It was slower and more expensive than a human.
So U.S. funding just evaporated for a decade. The classic tech bubble popping.
Completely. And the field didn't really recover until 1972, when Fred Jelinek at IBM did something totally counterintuitive.
Wait, is this the part where they stopped trying to teach computers grammar?
Yes. He actually noted that anytime a linguist left the room, their speech recognition rates improved.
That's hilarious.
It's true, though. Throwing pure statistics and mountains of data at the problem just worked way better than trying to program rigid written rules.
Okay, but if this purely statistical approach worked in the 70s, I got completely lost in our sources trying to figure out why the massive AI boom only happened recently.
Well, it comes down to scale and geometry. The notes mention Google's word2vec in 2013.
Yeah, mapping words as geometry. I didn't really get that. How do you map a word as a shape?
It's less like a shape and more like a map of relationships. The program assigned coordinates to words based on their meaning.
Okay, so how does that work in practice?
So the distance and direction between the word king and man on this map is the exact same distance and direction as queen to woman.
Oh, that makes total sense.
Yeah.
It gave the computer a mathematical way to understand context and relationships.
Right, not just frequencies.
But the real shift in the sources happens in 2017. The attention is all you need paper.
Yes, the transformer architecture.
Right, because before this, neural networks read words sequentially. Like reading a book through a tiny peephole, one word at a time.
Which is incredibly slow. The transformer abandoned that sequential reading entirely. It looked at the entire context simultaneously.
So instead of just seeing the word bank, it sees the whole page.
Exactly. It instantly calculates that bank is surrounded by river and water, not money and vault.
And because it's looking at everything at once, it doesn't have to wait to process word by word. You can train it massively in parallel. using GPUs.
Yeah, those chips originally designed for intense video game graphics. They just happen to be perfect for millions of simultaneous math equations.
It's wild. Modern AI models are essentially just scaling up Markov's token guessing game.
But processing the entire internet at lightning speed across thousands of gaming chips.
So when you use a chatbot today, you're interacting with three intersecting histories: logic machines, neural networks, and a 1,000-year-old codebreaker's trick.
It all comes back to predicting what comes next based on patterns.
Which leaves us with a lingering question. Back in the 1800s, computer pioneer Ada Lovelace stated that a machine has no pretensions whatever to originate anything.
Right, that classic quote.
Yeah. So if modern AI is simply mathematically predicting the next word based on our own hidden language statistics,
Yeah.
is it actually creating that poem you asked for?
Or is it just holding up a giant mathematical mirror to ourselves?
Something to think about the next time the machine feels a little too human.